everybody, the Lord Root here, and today we are going to take another look at Unity. This time we're going to do a Pong game. Pong is a fairly easy game to do in Unity. In fact, it's a fairly easy game to do in most programming environments. And it's, in fact, erroneously thought to be the first such video game. In fact, there was a video game called Space War, if I'm not mistaken, that ran on a PDP-8 somewhere in the 60s, or sometime in the 60s, and that is thought to maybe be the oldest video game. But in this case, we're going to do Pong. And I've already taken the liberty of creating our project hierarchy here and importing some assets because it just takes away time here if we don't. Well, let's think about what kind of game Pong is. Pong is certainly a top-down game. And so we won't really need 3D, but I'm going to use it here just, because we can. That means that we can use an orthographic camera here. Now, what we want to do is we actually want to get this guy up above the up above this still. So I'm going to have it point down. You get it close to 10 or so. And just to get an idea if this works, we'll go into game mode rather, and we will create a sphere that represents our ball. We'll reset the position. Let's see. Maybe -90 is what we want. Well, we'll do perspective first. That should help us just a... Oh, I'm rotating in the wrong direction. We want to rotate in the X direction here. And we'll go back to orthographic. So the deal with orthographic projections is that they're meant to reduce distortion. In your perspective projection, you get distortion associated with the with the depth. In this case, that's not so. In fact, we can move this guy up just a little bit. And I'm going to take our ball here. I'm going to reduce its dimensions. And I'm going to create a label for it. We'll call this the ball. Now we'll come back to that, but for now we want to add in our lights. We can just leave it as the default because it seems to be okay for where we're at, and then I'm going to add, in addition to that, an empty game object that we will reset, and we will call the level. One more thing to add while we're at it. We're going to add the game controller as before. But there's something to note about the game controller, of course. The game controller, as it turns out, is going to handle a lot more than we did last time. We'll just reset that. I guess we don't technically need to reset it, but it's nice to. We'll add a new script component that we'll call game controller. Move that guy up in there. We'll do the same for the ball. And in fact, while we're on the ball, I'm going to add something else. I'm going to add an audio source as well. Because you can see I've already got two lines here, or two, not lines, but samples. And I'm going to drag this hit sample in. Now I want to reduce that to 0.5. And then I want to go to this guy here and turn off play on awake. That leaves us our script that we'll want to create. We'll call this ball controller. Move this guy up here, and then we will work on the level. So the level is really just two sidewalls and two goals. And it's best to work on the level in the game view so that you can see where everything is going to be placed, because our camera isn't going to move. So let's go through, and why don't we do two things? Let's set the X scale of this to 0.5, and we'll name this right wall, by the way. We can leave the collider on it. Z, we'll set the Z to 10. That seems to stretch out far enough. And then we will position this guy 5 away. Maybe not 5, how about 6.5? Why don't we duplicate this guy and name this guy the left wall? And invert its X here. So that we now have two walls on the side. Also, because it might be a little bit hard to see everything, I'm going to change this guy to black. There we go, it's looking like Pong so far. But we have an issue. You see, we now have to add in our goals, and so I'm going to add in a quad for that. We're not really going to be able to see our quad in this perspective, so I'm going to switch back to the perspective camera just temporarily. We'll call this player 1 goal, and if you think about it, this is kind of like soccer. The goal opposite to your paddle is the goal you want to get things into. Otherwise, there is no sort of, I guess, challenge to the game. You would avoid the ball, right? Well, let's move this guy up in Z1 so we can see what we're working with. In fact, I'm going to move this maybe up by 5. This seems to be a good place, and we will get the scale sorted out. So if we do maybe 15, that is too much. 10 is too little. If we do maybe 12.5, that will be the boundary that we have chosen for this. We could come in a little bit earlier, but I think 12.5 is going to be good. We're going to set this to a trigger, add a script called goal controller to it, and I'm going to make this a prefab because, as it turns out, we have two of them, and it may be convenient for us to deal with this. So let's put it under prefabs. We'll just call this guy goal. Maybe set this guy here. So we have goal. This is player 1 goal. 12.5. And set this guy to 0. Yeah, one of the issues here is that this shouldn't be modified at all. Player 1 goal. Now we need another goal, and we can drag that up there, but you'll notice we have a bit of a problem now. We can't see that goal. That goal probably cannot be seen because of something called occlusion culling, or depth culling rather, to where we have these normals calculated against the quad, and we can only display, or the renderer rather can only display the quad rather when it is facing its normal direction. So what we can do is we can simply go to the Y here. That was 12.5. Let's set this down to a negative, I think it was 5, was it? Negative 5 down here. And then we're going to go around the Y-axis and we're going to rotate this. Call this guy player to goal. Let me just go down here and make sure everything's sized correctly. Okay, so that's pretty much it for the basic level. We can go back to ortho now. And in fact, we want to. We'll go back to our orthographic deal here. The far really does not have to be that grand. But we have one more thing to add. We want to add the player as well. I've decided to use a capsule for this. And we can put this direction in the z-axis or the x-axis maybe. No idea why. Oh, that's the capsule collider. I understand why. Yeah, we'll just leave it to y-axis then. This is actually for something else here. We want to rotate this along the x-axis. Maybe along the z-axis would be better. 90 degrees. And I'm going to make this guy maybe 1.5 units long. It actually seems to be a little bit big. I think if we do one here, that'll be okay. And we'll call this guy a player. We'll attach a Playercontroller Script to it. And you'll note I'm waiting to work on these scripts because they all sort of depend on each other in some way or another. Tag this guy as a player. And then move him down. So this is player 1. In terms of our Y, we'll move him maybe down to 4.5. And we'll duplicate this guy. And this will be player 2. Okay, let's get cracking. First of all, let's go to this goal here. That is in fact a trigger. Let's start with the ball controller. We're going to have really two things here. The first is we're going to use a new method called void on collision inner. And this is for collisions rather than triggers. So we'll say here collision C. We're not going to use it. We're going to say audio, play one shot, audio dot clip. And this will give us our sound. Now additionally, however, we want this guy going in a random direction. So we can do that as well. We'll have a public function called reset. This is going to get called by the game controller as well. And we're actually going to use a little bit of trigonometry here. And so before I do this, let's do a couple of things. The first thing we want to do is we want to attach a rigid body to this ball. That's something I forgot to do. In fact, we want to attach it to the player as well. We'll go back and work on the player's rigid body here in a bit, but you can see that guy got propagated out there. And then we'll add this guy's rigid body as well. Now we don't really want any drag, and we definitely do not want to use gravity. But what about everything else? Well, let's just start by, when we call reset, let's set our velocity to, I don't know, we're not going to do mutual recursion. We'll say this rigid body velocity is equal to vector 3 down. Now let's see what happens here. Oh, yeah, these guys are colliding. Player 2 needs to be up here. Now we're not moving, of course, because I forgot to do one critical thing. I forgot to call reset in the start method. Oh, what is going on here? I think... Oh, these guys have gravity, I bet. We'll just go to our player real quick and turn that off. In addition to that, well, we'll just leave that as is. The ball is not moving. So the question is why? Rigid body seems fine. Let's try giving it some speed. Maybe that'll work. It is. Oh, we're having it going down. We want it to go back. Because remember, in this case, our Z is our forward back direction. So, let's just go ahead real quick. We don't want this guy to move down, but we want to constrain our motion. So we'll freeze both rotation. In fact, we'll just leave X the only one unconstrained. Maybe. Oh yeah, I need to do it here in the prefab. Yeah, you need to... So yeah, this guy just, you know, stands there. We don't want that. We want this ball to bounce. So I'm going to create a new folder under materials, and we're going to call this physics as opposed to visual materials. And there's really there's a difference here. You see, physics materials you attach to, I believe, the collider, and that will, you know, allow you to specify the properties here. Now, Pong has perfectly elastic collisions where the paddles essentially have infinite mass. And so we want to do a couple of things. Friction is, of course, down to 0. Bounciness is going to be maximal. We will rename this guy here to bouncy here. And if we go to the ball, we can drag this guy over to the collider's physics material. and it's still not bouncing. Well, why might that be? We could put such a material on here. We can set friction is going to be minimum here, bounce is going to be maximum, and that will ignore the paddle. But the main deal that's going on here is that this guy really should not respond to forces. So if we go to our player and instead make it kinematic, then what will happen is this guy will bounce around like this. And that's because there will be no momentum transferred to those paddles. So the ball does not lose any momentum as a result. Very nice. So, yeah, there's that deal. What we're going to do here, then, is we're going to attach to our game object, or rather our game controller, we're going to attach an audio source. In fact, I'll just drag the score on here. This guy is going to have 0.5. We can't go out of bounds yet, but I do want to work a little bit on the controller, and for that, or the player, and for that we actually need to do some things for the ball. So let's create a constant float, which is equal to 10. And you know how I said in the last tutorial that a vector is, either in rectangular form or it could be in radial form? Well, let's go to maybe Paint real quick, and I'll kind of give you an idea of how we're going to approach this. In trigonometry, there's this guy called the unit circle, and we'll just draw that guy out right here. Say this is our unit circle, and we have in the center R or so, and it's really not a pen. I think this is yeah, I'm kind of used to the way that GIMP does it. Let's just say that this crudely drawn line is our circle here. Now this circle has a radius of 1, right? This is theta is equal to 0 degrees. And let's say that we have another angle here, like this. And this is angle phi. Well then, this creates a coordinate pair, and that's going to be cosine of phi and sine of phi. And this will give you those x and y coordinates. So at 45 degrees, that's going to be the square root of 2 for both of these. Or 2 over the square root. 2 over the square root of 2, I believe, is what it's going to be. The square root of 2 is greater than 1, so it can't be that. And yeah, square root of 2 over 2. There we go. And so this will give us our xy position for this point on the circle. That if we were to draw a line normal to it, it would be tangent to the circle. And so this is what we want to use in order to determine our direction. Now, what we will do in this case is we will have a float here called, I'll I don't know, let's call it angle. And I'm going to use mathf, or rather random, range. This guy is going to be probably something like 45 degrees is a lower bound. This is moving up, right? And 135. This is the same as negative 45 to 45 plus 90 degrees. This will give us a random angle here. Now to calculate our new vector, all we have to do is say velocity is equal to new vector 3 mathf dot cosine of angle. There's no angle in the y, and mathf dot sine of the angle. And the reason we're using this particular combination here is because your cosine in this case gives you your x component, and your sine gives you your y component. There are other things we need to do as well. We need to say this rigid body position is equal to vector 3.0. That'll place it in the center, and then this rigid body rotation is equal to vector, or actually not vector 3, we want to use a quaternion. So a quaternion is kind of a weird extension of a complex number. Those of you who have studied complex numbers in maybe your algebra classes know there's an imaginary component to a complex number. But in this case, for a quaternion, this represents a matrix that could be multiplied by a vector of 3 imaginary components. So what we want to do is we want to set this to the identity matrix. Quaternions, as it turns out, are very useful to us because using Euler angles, which is what we did last time for the camera, it's possible if your camera's moving around that you'd encounter this thing called Gimbal Lock. So what we're doing here is reset position, calculate effective velocity, and then finally what we'll do here is we'll multiply our vector within this unit circle by our speed. Now that's really not enough for us. We want, no, don't use the original. Use original, there we go. Let's go ahead and simply go here and do void on trigger on, well, I have caps lock on. Must be sticky keys. This is rather annoying. Let me figure out exactly what's up with that. I'll be right back. Okay, we should be back. I think it was paint.net that was causing it, but that's okay. What we'll basically do is we will say, here we have this, two things we want. First of all, we want public int for player. That'll be the goal that this player is for. And then we also will assume for now that there is a method within the game controller, which we do need to cache. This guy, again, you do want to cache it ahead of time because this lookup process is really quite expensive. So we will say game controller get component game controller. And there we go. Now let's assume for a moment that there's a method in here called GC score, and we'll pass in for player. And let me just make sure this guy is running again. You never can be too careful about that. We have another guy here. Let's add a public function called public void score int for player. And let's also add a public ball controller, ball, two player controllers here. And I'm going to go ahead and take the initiative here. We're going to be adding text to our game, so I'm going to import Unity engine.ui. I'm going to have score label 1. That's not texture, that is text. Score label 2. What else might we need? The Unity engine.ui here. Well, we want scores as well. Yeah, let's make this guy an array. And let us do some initialization here. So we have the players, of course, but we also have the scores as well in the score labels. So I'm going to create a player controller array, and this actually is not, this is going to be private. You could make these guys public if you really wanted to. But I'm not going to do that. Doing it this way does have its advantages, because we could use the get refined objects with tags, or tag rather, but that might give it in an order that is not agreeable to us. I think it depends on their order in the hierarchy, so in this case we're good. We'll just say scores equals new int array 0 and 0. What is an array anyway? Well, an array is just a collection of similar values that are contiguous. And so in this case we're creating this deal that holds our two scores for us. Likewise, players is going to be equal to a new player controller. Let's say player 1 and player 2. Finally, score labels is going to be equal to a new text, and that's going to be score label 1, score label 2. Now, of course, we can go back and handle this score later, but we want to do a couple of things here. Now that we have a ball, we can say ball.reset. And that will automatically reset the ball for us. But we may also want to play our audio clip. So we'll say audio, play one shot to only play it once, and audio.clip, because we have our one clip attached to it. This will be enough for us for now. We can go back here. This guy should get a random direction. And the reason that didn't work is because I did not set any of the references. Let me just go ahead and set a couple of them here. Well, player 1 and player 2 here. And you can see we're sort of randomly moving about. This isn't ideal for a Pong game, but you can see we've already got those cool physics going on. Worst case scenario is something like that happens. So one thing we could do in order to mitigate that is we could change the angle. I am not going to bother doing that right now because we're at least satisfied that our scores are like this. Again, we want to add a canvas here so that we can see these guys. And really, it might even help if we look at the level here. Let's create a plane. Or not a plane, rather. Let's create a quad that'll sort of serve as our center line here. If we go to this quad, no collider will be necessary here. In fact, why don't we just delete that collider because it's not going to do anything for us. Let's set rotation about the x-axis to 90 so that we can see this. We already know that x is like 13.5, and then in our z direction, I guess this is y actually, we'll set this to something reasonable like 0.25. And we can maybe add a material to that as well. Let's just add ourselves a new material here. We'll call this center line. And that is a diffuse material there. Drag that here, and then if we go to edit here, why don't we make this guy have a texture of some kind? Now, part of the issue is that we really don't have a good texture for this. We could use a particle, for instance. That could be interesting. Could use a decal here as well. But ultimately, for some reason or another, I think it might help if maybe we did something maybe kind of like this. Let's go to paint.net again. And let's just go to our image here. Why don't we maybe... GIMP's just as good for this, by the way. I'm trying to remember how we set this guy up here. I think if we go to image and resize, instead of going 800 by 600, let's go maybe, I don't know, 8 by 8. We do not want to maintain our aspect ratio here. And why don't we zoom in a little bit? And actually, I think 8 by 16 is better. If we go to this image and go to canvas size again, or image size, let's do a width of 16, and we will just put in this goal line here. Fill that guy on up, and then there's a line tool there. I think that's what we want. Maybe not. This is why I like GIMP a little bit better. But let's take this guy here, film, and then save. I am going to go to my documents where I have this thing saved. Go to assets, materials, visual, and we will call this, oh, I don't know, centerline.png. And there we go. We can set this guy here as a diffuse material. We'll go with centerline. If we go here, this texture we want to repeat. We do not want too much going on here. And it'd be kind of interesting to see why it is that this guy does not want to accept our centerline material. Because that is rather odd. Does that have our centerline material to begin with? It does not look like it, so let's call this the centerline. Let's attach this material to this guy. That is not repeating itself like I want it to. Wrap mode, clamp, alpha from grayscale, max size 32. Let's see if we can figure this out. These are all of the different things here. Repeat, clamp. That is kind of interesting why we cannot get this guy. We go here. Oh, tiling. And I will be right back. Okay, so we are back, and I did figure out the issue here. If you look at the tiling here, we can actually change the X tiling to get the center line the way we want it. So I can maybe set it to 4, possibly to 8. I think it's possible to set an offset of some kind so that it doesn't clip this guy, but it does not seem to work as such. I'll have to come back to that later. But now we have a couple of issues. Let's prepare for something that we hadn't thought about. We might have 2 players here, as it turns out. And we want to prepare for that. So I'm going to go to project settings under the edit menu and hit input. And I'm just going to add an additional axis. This guy will be named, I don't know, why don't we call this guy horizontal 2. And positive button or negative button will be J. This guy will be L. We're not going to have an alternate button here. Let's just make sure we get everything from the horizontal here. Gravity is 3. Sensitivity is 3. And we're going to snap here. So that gives us another axis that we can use. But first of all, I do want to go back to this Playercontroller Script, which we can do now, because we're going to really have to think about how we're going to manage this. And so we'll bring this guy up here. I'm going to add in a public function called move. And this will be, this will take in an int. for the direction. But we'll just make it a float. There's no reason not to. It might make things a little bit easier in the long run. First thing we really want to do here is we want to take this, well, we want to even think about how we're going to do it. If you look at our player, you'll notice that we are kinematic. And that is a bit of an issue because a kinematic object cannot deal with velocity as such. So we're going to have to do our translation manually. So here in this case, we could do a number of things. First of all, I want to scale the direction by time.delta time. And what this does specifically is it calculates the time between this point and the last frame. Very useful for us indeed. But we have an issue now, because what we need in particular is we need this object's transform, or its position rather. So as far as the direction is concerned, we'll also want to scale this by a constant speed. I think maybe 7.5 is okay for this. That means that it can move 7.5 Unity units in 1 second, and this will get scaled down appropriately. So what we'll do here now is we will get our position, and the way we can do that is we could say vector3 position equals this rigid body and transform.position. Now we can't really just do this. We'd like to say pos x is equal to mathf.clamp pos.x plus in this case our direction, and we know that we're bounded between negative 13 and 13 respectively. That is not really going to be what we can do here. So instead what we want to do, and I'll show you why, in fact. This guy, as it turns out, is a temporary. If we look at our console, well, in this case it says we cannot convert that because I did not put the right suffix on there. But if we put the right suffix on there, we still couldn't do this because, or maybe we can. That's rather interesting. We'll give this a shot. You know, sometimes it won't let you do this because of the fact that it is a temporary. But we have our move script here. When it comes to structs and properties in C#, or with fields rather, that does become a bit of an issue. We're going to change this to fixed update now. And we're going to use a very interesting pattern. We're going to wrap this around a function called move player, and that will be the index of the player and also the real input here. So we got two options. We can use the AI to move this, or we can use the and we'll just take away that boolean. I've been doing a lot of Java at work lately, and we're going to have some things here. We're going to have private float. We will call this guy oh, I don't know, track. We'll pass in the player controller here. And for now, let's just return 1. In fact, let's just go ahead and implement this, just to show you how this might work. So, basically the idea is we have the position of the player, and we will just call that, we'll get the rigid body there, P rigid body transform position X. We also have the player of the ball, or the position of the ball rather, not the player of it. And what we'll do there is we'll get the transform position X there. And then we'll just have an X is equal to, in this case, we want to see which direction we want to go. We want to get a vector for the ball. So we're going to say the ball's position minus our position here. Then we'll say if X is equal to 0, those may actually have to be floating point values. We'll say return -1 or return 0. We don't want to move it all in this case. Else, if X is greater than 0, return 1. And I do not know what happened there. Sometimes MonoDevelop gets confused like this. Else, return -1. And so we will just, for now, have this guy here. We'll have float direction is equal to track here. We'll populate that. We'll say player controller P is equal to players sub I. And again, it's worth noting that arrays are subscripted starting with 0. So 0 is the first element here. I'm not sure if I said that or not, but that's what we have. And then we'll pass in P. And then we will finally say P dot move direction. So let's go ahead in this fixed update function. We'll say move player, how about 1 or 0, that's the first player, and then false. And then move player, maybe 1, and then false here. Now if we go up to here, can't convert float to int, why not? Oh yes, precision issues, it looks like. Well, that is easily rectified. So these guys are not moving around, and the question is why? Do we have the right player here? Let's just do a debug.log have p name. Let's see if anything is happening here, because you know it should be. Okay, so that is interesting. We don't have... Oh, you know what it is? We need to set now, this isn't a reference, but it needs to be. We'll say this rigid body transform position is equal to pause. Let's do that. this is the point where it would be really useful if some of these guys were properties. And now you can see we sort of have a worst case scenario here to where this guy's sort of trapped here. I'll just turn that off for now. But yeah, this guy will track these guys. I'm going to turn down the speed just a little bit so that we can fail. And that's one way to do it. We can also say private float track. Really we don't need the player controller here. Let's say instead of track, get player input int I, and then we'll say here float x, and then we'll say if I is equal to 0. And man, I really hate the way that this IDE does my braces sometimes. So we'll say x is equal to input get axis horizontal. Otherwise, we'll say else x is equal to input dot get axis horizontal concatenated with I plus 1, and then we'll just simply return x. So now we can say that this guy here is a player, and we'll say if is real input, or if real input rather, if real input then direction is equal to get player input, and we'll just pass in this guy here. And now we should be able to move the paddle around, which I am presently doing. But there's a bit of an issue. You see, we can go off screen. Not exactly what we want to do. So we have to remember a couple of things when we do this. You see, when we go back to this guy here, to our player controller, we actually have a constant width that we need to be aware of, because we have our so-called radius. It's more like a semi-major axis on this guy. And so we'll say plus radius here. So this 13 is the bounds here. And basically what this clamp function does is that it prevents you from, it basically makes this the maximum that you can have. So if you get any greater than this, it'll take this 13.5, which is our level width, and in reality we should make that a constant too. We'll just call that 13.5, and we'll say here that that is our level width. That may actually need to be divided a little bit by 2, because this is actually the total width of the level. So this is actually 6.25. Okay, there we go. Let's go back to our game. And that was actually a little bit too much. We can go back to our paddle and figure out this has a scale of 1. I was thinking of something else, so let's just go ahead now and set the scale of this guy to 1. And we have now faked a collision. There's really only one more thing to do here, and that is to get ourselves our scoreboard going. So we are going to abuse a little bit of a trick here. What we are going to do is we are going to go to our UI here and create a canvas. And under that, we will create two text fields. One of them, of course, will be player one's text field for their score, and we'll have player two. So this is player one's text. And what we'll want to do is we'll want to center this in both directions. I am going to make this completely white. And give us a size of 32. We'll increase this to like 40 or something, and then we'll push this down by 30 to indicate the new text here. I'm going to delete this guy and duplicate it. And we will move this up to 30 as well. And this will be player 2's score. Now all we have to do is go back to our game controller. This guy should have been changed here. We'll go back to our game controller here. We'll drag these text labels onto here. And we just have one little bit of code to write left. If we go to our game controller here, we will create a function called private update score. And this will be basically something like this. We have our labels already conveniently in an array, and so we'll say score labels sub I is equal to scores sub I plus 1. Now when we go to score, all we have to do is say scores sub I plus 1, or i's plus plus rather. 4-player, I think, is the name of it. And then update score for player. And then up here, we will go ahead and reset the score counter here. So update score 0 and update score 1. Now this is more or less it. We will run compiler errors. What are these compiler errors? Cannot convert type string to UI text. Oh, yeah, I know why. We actually have to use the text field on the score label for this. Okay. Well, now you can see we won. You know, it could be a little bit annoying with the sounds here, it being as they are. 4-player, I do not believe is set correctly here. I need to go down to the goal and make sure that we actually set that correctly. I guess we didn't. Yeah, we actually have to go back to the goal script and set the 4-player variable like this. And that will prevent us from, doing things. Minor tweaks on this may include going to the ball and maybe lowering the volume a bit. 0.5 is a bit loud. Sometimes with these games, I'm just going to go to the game controller to not have this play on awake. Sometimes with these games, it's only really a matter of testing that'll tell you whether or not, like, for instance, your interface is messed up, or whatever seems to be happening here. One more thing just to show that this works. I'm going to go back to the game controller and I'm going to set this guy down here to the... Well, I'm going to make one more tweak just to make it a little bit easier on us. We're going to have a public boolean player1 is human and a public boolean player2 is human here. We don't really need to put these in an array because they aren't being referenced anywhere. But yeah, if we go to now player 1 is human and player 2 is human. Right now, as it stands, because we have not set these properties, these guys will track the ball and play. Ooh, that's interesting. What happened here? It's another bug. I bet you what happened is that we did not freeze rotation on or constrain the Y position here. So it flew above the paddle. So yeah, you got this issue here to where these guys are deadlocked and have no way to get out of it. And they will just move to the corner. Just like so. Because they could use an AI tweak. Incidentally, that's an exercise left to the reader. Because ideally what you want to do is predict where the ball's going to be and move towards it. Well, let's just go back to our game controller. Now we can set both of these guys to human, and I am controlling both of these like so. I'm not very good at moving around two paddles. But, yeah, that's pretty much the game here. The, top guy is winning. But that doesn't matter too much. I think with a little bit of AI tweaks, this can... Oops. With a little bit of AI tweaking, this, could actually be a relatively good Pong game, and I challenge you to make such a change to it. But I think we'll leave it at that for now. Until then, this has been Thy Lord Root, and I will see you later.